We often encapsulate the data access for our application into a data service that can be used by any component or other service that needs it. In that data service, we use Angular's HTTP client service to send requests. In this example, we send a GET request. Let's walk through this code. We import the HTTP client service and the HTTP response from the Angular 2 HTTP library, and we import observable from the RSJX observable library. Next, we define a constant identifying the URL to the web server. This is where we'll send our HTTP requests. We want to use Angular's HTTP client service in our data service, so we specify it as a dependency. Recall how to define a dependency in TypeScript? Yep, we add it to our class constructor. Recognize this syntax from the last module? It creates a private _HTTP variable and assigns the injected service instance to that variable. We can then use that variable to call the HTTP client service. And a side note here, now that this custom service has an injected dependency, the injectable decorator is required. In our data service, we have a method that calls HTTP GET and passes the URL of the web server. The HTTP GET method creates and returns an observable object that we then return from this method. Observables take advantage of generics to define the type of data it is observing. So we define this method return type as observable of iProductArray. In another part of our code where we use this service, we'll call this method and subscribe to the returned observable object. We'll talk more about that code in the next clip. But once the observable has a subscriber, it does its work. The Angular HTTP client service makes an asynchronous call to the defined URL, which processes our request. At some future point in time, the server returns the HTTP response, and the observable completes. We then process the response object using map, which is one of the reactive extension operators. Map projects each element of the observable sequence into a new format using the provided transform function. Note that each HTTP call is a single async operation, meaning that the observable sequence contains only one element, which is the HTTP response object. The argument to the map method is an arrow function that transforms the response to a JSON object, which in this case is an array of products. So this code basically transforms the raw HTTP response to an array of products. This array is returned with the observable completion notification. Note that depending on your server, the JSON result may be wrapped in another property, such as a data property. If that is the case, use response.json.data here. As you can imagine, there are many things that can go wrong when communicating with a back-end service. Everything from an invalid request to a lost connection. So let's add some exception handling. We'll add a catch and pass it the name of an error handling method. The error handling method gets one parameter, the error response object. In that method, we can handle the error as appropriate. We can send the error information to remote logging infrastructure or throw an error to the calling code. And notice here one more thing. The observable has a do operator that allows us to peek at the data returned from the server without disrupting the flow. We can use this operator when debugging to log data to the console, for example. Now let's add HTTP to our product service. Here is the product data service we created in the last module, with all of the hard-coded data. We want to modify our product service to get the product data using HTTP. Let's start at the top with the import statements. We import the HTTP client service and the HTTP response, and we import the observable. We want Angular to provide us an instance of the HTTP client service, so we identify it as a dependency in the constructor. We don't have a constructor yet, so let's add that first. Then we specify the parameter. Angular will then inject the HTTP client service instance into this variable. Now we need to identify the location of our web server. We'll specify that in a constant. This doesn't look like a valid URL to a web server. To keep things simple, the demonstration reads the data from a local JSON file that was provided with the starter files. That way, we don't need to set up an actual web server. To change this code to work against a web server, simply change this URL to point to an appropriate web server. And of course, you need to write the server-side code to return the list of products. It's finally time to delete our hard-coded data. So let's delete the hard-coded products from the getProducts method. Gone. We'll call the HTTP GET method here instead, passing in the defined URL. We'll need to change the return type as well. Now this method returns an observable of iProductArray. When we get a response back, we use the map operator to map the HTTP response to a product array using response.json. This code is not really complete without the exception handling, so let's add a catch method that calls a local handleError method. In this method, we can log or handle errors any way we want. For our sample application, we simply log to the console and throw an error to the calling code. Let's also try out the do operator. The do operator lets us peek at the response data. We use json.stringify to display that data in a nicer format. So our getProducts method is complete. We can add other methods here to post or put data as well. We can't see the result of our hard work yet because we are not subscribing to this observable. Let's do that next.